this is problem 30 of Neetcode 150, Koko eating banana. So let's read the problem. You're given an integer array pile, where piles at the index I is the number of banana in that pile I. You're also giving an integer h, which represents the number of hours that you have to eat all the bananas. You may decide your bananas per hours eating rate, so we are free to decide what k is. Each hour, you may choose a pile of banana to eat a k amount of banana for an hour, and basically, if that pile is less than k, you are gonna have to finish the pile before uh, you start another one. So, for example, if I have a pile of 7 bananas and I eat 6 bananas per hours. In the first hours, I eat 6 bananas, so there is now 1 banana left in my pile. But on the second hour, I actually have to eat that 1 banana for the entire hour. I cannot eat 1 banana in that pile and now go to the other one to eat 5 bananas. All right, and we have to return the minimum value of k. Right, so um, this is a problem of the binary search section. So we are going to have to find a way to integrate the binary search in our solution. A brute force approach will basically be to try every values from 1 to the maximum number in that array. And one thing that we are sure is that the h value is never going to be less than the length of the array. So for example, we cannot have 3, right? Because if we actually have to take a minimum of 1 hour per pile, we cannot finish eating the entire piles in 3 hours. So the minimum that h can go is if we have an array of length 4, it's 4, meaning that we will have to eat at a rate of 9 bananas per hours to eat all piles in 4 hours. Okay, but in our case, we want to use the binary search to also improve our time complexity. So the first thing that we're gonna do is that we're gonna build an array um, with basically the values from 1 to 9, because we know that in the worst case, we are going to have to um, eat basically each pile in an hour. So the number of bananas that we're going to have to eat per hours is going to be equal to the maximum values in that array. Otherwise, if we have all the time in the world, so if we have 22 hours, we can actually handle eating 1 banana per hour. Okay, so it is going to be somewhere here. All right, so we are going to use a binary search, and we are going to have our start pointer here, our end pointer, and we're going to have our middle value. All right, so we're going to test our middle value, and we will see, okay, what if I eat 5 bananas? Okay, so in 1 hour I can finish this, in another hour I can finish this. It will take 2 hours to finish that, so now we're at 4 hours, and it will take another 3 hours to eat these 9 bananas. So it will basically be 1 plus 1 plus 2 plus 2. So it's gonna take me 6 hours, okay? So this is good, but basically the value of hours per of banana per hours has to be the least it can be. So knowing that we can do this in a very short amount of time, we are going to use binary search, and we are going to go to the left portion, or the left half of the array. So we're going to put our hand pointer here at one index to the left of the middle, and we're basically going to cross the rest here, okay? And we also have to keep track of basically the the response so far. So we have to make sure that 5 is stuck somewhere, because if like no values to the left actually works out, we are gonna use our 5, okay? But in our case, we are gonna go ahead and do the binary search for the other half of the array. So we're gonna take our 2, And how many hours is it gonna take us to eat basically 2 bananas per hours? It's gonna take us two here. It's gonna take two here as well. It's gonna take three here. It's gonna take five here. So basically 12 hours, right? But we don't have 12 hours, so we are not gonna choose this. Um, so what we're gonna do is basically that we're gonna move our, our start pointer to the right of the current middle here. And we're gonna cross that left section because we really just wanna focus on this here. All right, so now we are gonna pick, all right, let me just clean this a little bit. You know that this is crossed and this is crossed. And now we are checking for, three, sorry. So for three, it will take us 2 hours. 1 hour to eat the pulp one banana. It will take us 2 hours here. And it will take us 3 hours. Right? So if you make the calculation, this is giving us 8. Exactly what we need. I can't do much better here because if we go to the right, well, you'll see that it will take 1, 2, 3, 4, 5, 6, 7. It will take 7 hours. So we will make it, but basically the hour will be greater, and you want to return a minimum value. So our output will be 3 in this case. All right. So let's go ahead and code this. So first we're gonna set our start pointer and our end pointer. And our start pointer is gonna be at the index 0. And our end pointer is basically gonna be the maximum value in the piles. Okay. And we want to keep track of the maximum output we've seen so far. So we're gonna call this res. Well, so far we are gonna set it to basically the right endpoint because we know that the right endpoints is gonna work no matter what. So we can only update it to something lower after this. And now we're gonna do our binary search. So basically, while the start pointer is smaller or equal to the end pointer, right? Well, first you want to find the middle value, which is going to be the start plus the end with integer division by few. All right. And this is where we want to calculate the time it will take to basically eat all the bananas with our middle value. So we will first write like time taken. All right, we're gonna set that to 0, and now we're gonna go for each values. So for pile in piles, we're gonna say that the time taken is gonna be itself plus so we are gonna have to use a math function here, math.ceil. So if we have like 4.1, math.ceil is gonna take 5. All right, so this is what it's gonna do. Okay. And after this, we can actually take our pal and divide by 4. Divided by so you can take your pal and divided by our middle, right? So this is going to give us the total time that we need. And now we can check if basically the time taken is smaller or equal um, to the previous answer that we had, or no, in this case we want to check if basically it is smaller or equal to h, which h is the maximum amount of time that we have. And in this case we will want to make sure that our greatest value so far um, is the middle. All right, so we're going to set that to the middle, and after this we can take a look at the left side of the array to see if we can figure out a smaller solution. So at this point we're going to set our end equal to the middle minus 1. All right, and otherwise if the first statement is false, it must mean that it took us too many time, too long. So we're gonna have to set our start. Right. So in this case, we're gonna have to set our start to basically to the middle plus 1. All right. And this is the entire algorithm. So we can now return rest, and everything should work. And we get an error here, start, because of our indentation. So let's go ahead and indent this. You have another error because right, okay, I used yes, so here I I wrote error as if I was using the right pointer, but it has to be the hand pointer. So let's see if I think the rest will be fine. Okay, what is the error here? Division by 0. Okay. So okay, so basically here we've been given okay, the problem here is that we must start at our start must be at 1, because basically you cannot eat 0 banana per hour and expect to have a solution here. So the minimum that you can start with, or that you can set your left pointer at, is 1 rather than 0. Okay, so hopefully you found the error before I did. And other than that, I hope you found the video helpful, and I hope to see you in the next one.